In this lesson, we'll cover several subjects. These are things that you often run into during web development, and at the same time, they are also relatively straightforward and easy to understand. So I grouped them together into one lesson I call the bits and pieces of web programming. Specifically, in this lesson, we'll talk about logging, testing, and handling files and exceptions. Logging is to record events happen during software execution. A simple form of logging is using some print statements to assist debugging. For example, suppose I suspect that I have an infinite loop in my code. I put print statements in the code to output loop started and loop finished. And if I run the code and only see the loop started message, I know the code is stuck in an infinite loop. We probably all had done something like this when we learned our first programming language. The question is, with powerful GUI debuggers and profilers in modern IDEs, why do we still need printouts like this to assist debugging? The answer is that the logging is not just useful during the development phase of the software. Imagine that you develop some software and sold it to your customers. And one day a customer comes to you and tells you that your software crashed. The customer may be able to tell you something about what he or she did prior to the crash. For example, the customer may say, I filled a text box here and clicked a button there. But the problem is that the customer's description may not be accurate or complete to begin with. And on top of that, the customer cannot tell you what happened behind the scene. For example, whether there were other clients accessing the system at that time, or whether there were any anomalies in various components of the software. Without accurate information about the events leading up to the crash, it's extremely difficult and often impossible to fix the problem. And this is why logging is extremely important. It's a simple yet reliable way to keep track of the operations of your software. It doesn't require any IDE or any specific software or hardware platform, so it works anywhere, anytime. And it provides invaluable information not just during development, but also for the long-term maintenance, monitoring, and support of the software. Although we can use system.out.print to do some basic logging, we need tools designed specifically for logging to do it effectively and efficiently. Here are some requirements for those kinds of tools. First, because outputting logging messages does incur some overhead, a good logging tool should minimize this overhead to make logging as efficiently as possible. Also, it would be nice if the logging tool supports different types of output, for example, output to console or file or to a database. And very importantly, a logging tool should support different so-called logging levels or message levels. The idea is that not all logging messages are created equal. For example, you may have a logging message that outputs the value of a variable in a method. This message is useful for developers for debugging purposes, but a system administrator may not need to see this message. And then you could have a message that outputs the exception when a serious error happens, and obviously a system admin would want to see that one. By dividing logging messages into different levels, it's possible to control the messages recorded and displayed under different settings. Here are the 6 most commonly used message levels, ordered by how severe the event is. Fatal, error, and warn mean the message is about some kind of error. Respectively, an error the system cannot recover from, or an error the system can handle, or just a possible error. Info, debug, and trace mean the message is for informational or debugging purposes. And last but not least, a good logging tool should be easy to configure. When it comes to logging in Java, the situation is a bit messy. Because when Java was first released, it didn't include a logging library, so several third-party logging libraries were developed, and the Log4j was one of them. And then later, JDK added its own logging library to the mix. Because there were so many logging libraries, people wanted to kind of unify them. The idea is to create a common logging API, so if an application uses this API, the application can use any of the logging library without being tied to a specific one. This idea led to the development of the logging API libraries, and the two popular ones are Apache Commons Logging and the Simple Logging Facade for Java, or SLF4J. So the question is, which one or ones should we choose? The recommendation is that you should use a logging API library, which gives you the flexibility to use different logging implementations without changing application code. Between Commons Logging and SLF4J, SLF4J has better performance and reliability due to its simpler design. As for logging implementation library, everybody uses Log4j these days because of its performance, rich features, and easy configuration. The only reason you choose JDK's own logging library over Log4j is if you really don't want to have any additional dependency in your projects. Now let's see an example. Here I have an example showing how to use showing how to do basic logging. The first thing we do is, of course, we need to include the dependency. We only need one dependency for logging. It has a weird name. It says something about LF is called SLF4J-log4j12. What it means is it's using SL4J API, and it's statically linked to using the logging implementation log4j 1.2 version. So if you look at the dependency hierarchy, you can see that once we included this dependency, it automatically adds a couple of other dependencies, which is the SLF4J API library and then the log4j logging implementation library. And notice that it says 1.2.16, and that's because we're using this dependency that's linked to log4j version 1.2. So once we have that dependency, we can then use it in our code. I have two classes here that uses some kind of logging, and one class is called foo and the other one is called bar. As you can see, they are pretty much the same, except the name and also the different output in the output method. To create a logger to use for this class, the typical way is to create the logger as a static field in this class. So you can say logger and then logger factory get logger and then the class name, and this logger is a static member of the class, and that's it. So what this means is that all the instances or the objects of this class will share the same logger, and that's typically what we want. And to use this logger, we can use it more or less like a print statement. So we can say print out this message, print out this message, print out this message, and so on. And the method name corresponds to the message or logging level. For example, when we say error, it means that this message will be logged at the error level, and this one is at the warning level, this one is at the info level, and so on and so forth. And same thing for here. the method indicates a login level, and then whatever message we want to output. So if we run this code, I have a main method here, which creates a full object, creates a bar object, and print out the and call the output method. So if we run this, and we can see that it says class full, which is generated by this printout statement, and then 5 login messages, and the same for the bar class, and the output is more or less what we would expect. Now let's see the log4j configuration file, and this configuration file controls the output of the log messages. A log4j configuration file can be either an XML file, typically called log4j.xml, or a Java properties file, typically called log4j.properties. The XML format is a bit more verbose, which I actually prefer as it's easier to understand. In any case, the configuration file should be in class paths, which means in a Maven project it should be under source main resources. And also, you probably don't want to create a log4j configuration file from scratch. It's much easier to copy over an existing one and then just make some changes as necessary. So if we look at this log4j configuration file, the first thing we notice here is something called an appender. Appenders in log4j determines the output type and output format. For example, here I have 2 appenders. One for outputting to console, as you can tell by the class name, which says console appender, and the other one output to file, as you can tell from the class name file appender. The format of the output is controlled something called a pattern layout. If you look at the documentation of pattern layout, you can see that with pattern layout, we can control the output format with a string like this. And the characters in the string have specific meanings as explained in this table, which we won't get into detail. Here, taking this as an example, for example, the letter D represents date, and the ISO 8601 represents the date format, and the letter P represents message level, and the capital C here is the full class name, and the M is the login message itself, and the N is a new line character. So we can manipulate this format string to change the output format of the login messages. For example, if we remove D, we can see that the login messages no longer include the timestamp. And if we remove P, you can see that the login messages no longer include the message level. Now, the second thing in log4j configuration is called a logger. A logger decides what appenders we use and what's the minimum login message level to output. Each application must have a root logger. Here I have a root logger that says we want to output to console. Notice that this one references the console appender std out. And it says that we want to output to console all the messages that are at or above trace level. And this is why we're seeing all the logging messages from our code, from trace all the way up to error, and from trace all the way up to error. If, for example, I change this from trace to, let's say, 1, and you can see that now only the messages at the 1 or above level will be recorded. This is a very useful feature. Imagine, for example, that during development, you probably would want to see all the log messages, and or at least ones that are at or above debug. But once the software is ready to be released, and before deployment, you may want to change this to, for example, 1, so that when the software is deployed, it will only log the messages that are at warning or above level, instead of recording all the detailed debugging messages. So in other words, you just need to change one place in a configuration file. You can still leave all the logging statements in your code. They just won't be actually outputting anything during deployment. And this is an easy way to control what messages to output and what messages are not, depending on different environments and different phases of software development. And in addition to the root logger, we can also add additional loggers to apply different settings to different packages or classes in the project. So let me uncomment this one. So as you can see, we now have a separate logger, and the name of the logger is a package name. Notice that it says cs520 logging.foo, which matches this package name. And what this means is that this logger will be applied to all the classes that are under that package or under its sub-packages. Each logger can have its own logging level. So if we set the root logger to be at the warning level, and we set this one at the debug level, if we run the code, we can see that for the full class, we get all the logging messages at or above debug level, and for everything else, we get all the messages at 1 or above level. And this again is a very useful feature. For example, in a project, you would have some libraries that uses log4j and your own code that also uses log4j. And you can create a logger for your own code that has a low message level like debug. And for the libraries that you included in your project, you can set the logging level to a higher level like warning or info, and so that you don't get lots of log messages from the dependencies instead of from your own code. And of course, a logger can have its own appender. So for example, we could say for this logger, we use the file appender. And if we run this code again, and let's see, right, right, now we have a file here, and we can see that this file would have the logging messages from this logger, which include all the logging messages for class foo. Okay, so this is the story about logging. It's very, very important for software development, and as we can see, it's also very easy to add to a project. You just add a dependency, add a configuration file, and inside your code, you can create a logger and then call the logging statements, and that's more or less it. So it's important and easy to use, so please do use it in your projects. Now let's move on to testing. Testing, needless to say, is also very, very important in software development. At the method or class level, we need to do unit testing, and then we need to do testing between the interfaces of different system components, and then we need to test if the whole system works from end to end. And then after doing all the testing ourselves, we invite some users to do even more testing. Because all the testing that needs to be done, it's no surprise that we want to use some tools and libraries to help us with the testing. There are two commonly used testing frameworks in Java, JUnit and TestNG. JUnit is the more widely used one, but TestNG was considered technically superior for a while. These days, I think these two frameworks are more or less the same in terms of features and capabilities, so either one is fine. And for this class, I chose TestNG. You may be thinking, why do we need to use a test framework in the first place? Well, if your program is simple, you probably don't need one. But imagine that you are working on a large software project with a few hundred test cases. The first thing you want is probably automating the tests so you don't have to run them manually one by one. And because certain tests require certain preconditions, for example, you may need to populate a database before running some data access tests. Test automation also includes automatically setting up the environment required by some tests and automatically clean everything up after those tests are finished. Even with test automation, you probably don't want to run every test every time. For example, if you changed some data access code, you may want to only rerun the data access test, but not the others. And this requires the ability to group and select tests. And when you run tests, some of them may fail. It's often the case that some tests depend on the functions tested in some other tests. So if those tests fail, there's no need to waste time running the tests that depend on them. And the opposite of test dependency is test independency, in which case it should be possible to run tests that are independent of each other in parallel. And of course, after all the tests are completed, we want to generate nice-looking reports. We may also want to run tests from within our favorite IDEs to control tests using code, to inject dependencies into test cases, and so on and so forth. And a good testing framework should give us all of this. Because testing is an integral part of software development, the standard Maven project directory structure includes folders specifically for test code and test resources. Test code, of course, should go under source test Java, and the test resources should go under source test resources. The Maven plugin that runs the test is called Surefire. And during build, it will automatically run all the JUnit or TestNG test classes whose names end with test. Now let's add some test cases to the CS jobs project and some basic usage of TestNG. This is, by the way, the CS jobs example we did during our discussion about Spring Web and VC framework. And to add TestNG to it, we first need to add the dependencies, of course. So we first add the TestNG dependency. And we add Spring Test dependency, which integrates TestNG and JUnit with Spring projects. Spring Test. Where are you? Okay. Yeah, this one. So we'll pick the 4.1.6 version because that's what we've been using for other Spring dependencies. Okay, so now we have our dependencies, and then we can create our tests. So I'm going to create a test called user.test, and I'm going to put it under the package csjobs model DAO. The package of the test class doesn't really matter. I like to put it in the same package with the DAO, because later on I'll import the DAO object, but it doesn't have to be like that. You can put it in any package. Now we'll annotate this class with test annotation. Okay. And then we can create any number of test methods inside the test class. So let's say I create one called getUserById, and this one is supposed to test the getUserById method. As we saw in our examples in the homework, the typical way to create a test method is use the assert statement. And assert statement takes a Boolean expression. If the Boolean expression is true, nothing happens. And if nothing happens, the test is considered passed. If the Boolean expression evaluates to false, this assert statement will throw an exception, in which case the test is considered failed. So let's say we test if 1 plus 1 is 2. If we run this test, we'll right-click on this and select Run as TestNG test. And we'll see that this test passed. And this is how easy it is to include tests in a project. It's very, very simple. Just create a test class, some test methods, and then test some Boolean conditions, and then you can run them either as TestNG test cases in Eclipse using the TestNG plugin, or you can run them during Maven build, and so on and so forth. So it's really simple to create test classes. There's no reason not to do them. But of course, since we are doing a Spring project, we need to use dependency injection. In particular, if we want to test our database access methods, we have to inject a user DAO into this test in order to do that. And TestNG test classes and test methods don't support don't support dependency injection directly, so we have to do something more. And that something more is to basically change this test class into something that supports dependency injection, and that means using a Spring class as the superclass. So instead of using a regular Java class, in order to get the injected dependency, we have to inherit from a Spring class. And once we get the Spring class, we also need to tell Spring where that Spring bin configuration file is. Without that bin configuration file, of course, there's no bin to inject to begin with. And that bin configuration file typically is a file that needs to be on class path. So what we do here is we'll take this application context.xml and make a copy of it, and put it under source test resource. And so this file will be on class path during testing. Note that it's under test resource, not the main resource, because it's only used during testing. And this one, of course, is the one that has all the data access bins, including the data source plus all the DAOs and so on. So once we have that, we can then do our injection thing. So here, for example, we can say inject me user DAO, and then instead of testing 1 + 1 = 2, we can test let's say user DAO get user 1, and let me quickly see what is user 1. Okay, so user 1 is admin, so we'll say get user 1 and check if the username is admin. So if we run this test again, we can see that it says test run 1 failed, no failed, and no skipped. We can also see it here that this test has passed again. So that's good. If we look at the documentation of TestNG, particularly the annotations, we can see that other than test, there are many other annotations, and many of them are called before something, after something, and those annotations can be used on methods, so that those methods will be run before a certain test suite or a certain test or a certain test group. So in other words, those methods can be used to set up some preconditions used by a test suite or a test group. And similarly, the after methods can be used to clean up after a test suite or a test group is run. And for the test method, for the test annotation, there are many attributes that we can use to customize test. For example, we can say a test depends on some other test. If other test failed, there's no need to run this test because this test will fail as well, and so on and so forth. So we again don't have time to go into details, but do have a look at the annotations and the TestNG documentation in general. It's not very long and it's pretty concise and to the point, so it won't take too much time to browse through it and have some general idea of what it can do. Just to do another simple example to illustrate test dependency. So let's say we create another test called get users. And this one will assert user.get users, and size should be 2 because we pre-created 2 users in there. And we'll say this. We'll say this test depends on the test method called getUserById. So what this means is that if this test failed, then this test won't be run because chances are the database is not set up correctly or something, and there's no need to waste time running this test. To create an error, instead of checking whether it equals to admin, we'll check whether it's equals to CY_sum. And okay, so let's run this test again. Now we can see that it tried 2 test cases, and one of them failed, and the other one is skipped. Skipped meaning that this one is not even run. And so a failed test has a red cross there, and a skip one has a yellow one there. And you can see more examples of TestNG in the CSNS2 project. In particular, it uses something called a test suite file, which we can use to group a number of tests together. And it also uses a before suite method and an after suite method to automatically populate the database before testing and clean up the database after tests are done. So check out the CSNS2 example and take a brief look at the documentation about TestNG annotations. For more information about TestNG, please check out this documentation. And also, if you do lots of testing, I'd also recommend the book Next Generation Java Testing. One of the authors of the book, Cedric Bust, is the creator of the TestNG framework. This book is not just about TestNG, but also covers many different testing scenarios and methodologies. So it's quite instructive even if you don't use TestNG. Okay, that's the end of our discussion about testing and TestNG, and let's talk about file upload and download. Uploading files is a fairly common function in web applications. For example, you can upload your pictures to Facebook, upload attachments to Gmail, upload resumes to Indeed.com, or upload your homework to CSNS and so on. And of course, if you can upload files, you should be able to download them. So how do we do that? We know that on the client side, we need a form. It's not so different from any other form, except that first, the field for uploading a file is the input field with the type file. And second, the method of the form has to be post. And third, there has to be a encoding type attribute that says multi-part form data. Now let's add a form like this to the CS jobs project and see how we can do file upload and download. So I'm going to create a JSP called upload.jsp, and here I'm going to create a form. The action will go to the action will go to a URL called upload.html, and the method, of course, needs to be post, and there needs to be something called encoding type, and then what's that called? Multi-part / form data. So it's multi-part / form data, and we'll have a font field, which is an input field with the type file, and name is file, and we'll have a submit button. Let's say type is submit, name is upload, and the value is upload. Something like that. Let's run this code. Okay, so that one is here, and I'm going to add a link here so I can go there from the front page. So this one is for upload. Okay, and we know how to use this upload field, and we can, for example, upload a PowerPoint file. And because we haven't implemented anything to handle it yet, of course, we get a 404 error. But, but before we do that, we need to understand how this file is sent from the client to the server. And for that, let's set up a TCP IP monitor. So I'm going to use the local port 6000 to monitor the server at localhost 8080, which is basically this Tomcat server itself. And so here, I'll change this one to localhost 6000 and then CS jobs, this one. So what this one does is we'll submit this form to the proxy server running at port 6000, and this then should tell us what the request and response looks like. So let's refresh this, and let's try to upload this file. And oh, I think I didn't start the TCP IP monitor, so that's why. Let's try this again. Okay. So what we want to see is this one. So the response is for we already know that. But take a look at the request. So notice that the request is a post request, and it has a bunch of headers as before. And notice that unlike a typical GET request, the request body is not empty, and the request body in fact contains the uploaded file pieces1.ppt, and the content is not displayed here because it's a binary file, so the content is not displayable. But if we want, we can create a text document. Let's say we call it test1, and we'll say this file is supposed to be uploaded. And if we try this again, and this time we can see that again, this file is included in the body of the request, and in fact it includes all the content of the file that says this file is supposed to be uploaded, and so on and so forth. So let me stop this. So what I'm trying to show here is that there's no separate secret channels to upload files. No matter how large a file is, it is sent to the server as part of an HTTP request. In particular, the file is encoded as inside the request body, just like any other post parameters. So the important thing about this is that once we understand that all the uploaded files are just part of HTTP request, things become simple because we know that if everything is inside the HTTP request, if we want to get an uploaded file out of the request, we just need to parse the request, and that's it. And of course, there are libraries to do that. We don't have to read up the HTTP specification about how those files are encoded and then try to write a parser ourselves. There are libraries that have already done that. And here's a quick example showing how to use the Commons file upload library to process the uploaded file. So what you would do if you want to use this library is to include it as a dependency in your project, and then this library provides a number of classes. In particular, there's a class called the servlet file upload. You create an object of that class, and you can then use that object to parse the request. So the parser will return a number of items which it gets out of the request body, and then you go through those items one by one. And some of those items are regular form field, like in this case, there would be an item called upload, and that simply corresponds to the submit button, and it's called a form field in the Commons file upload library, and we can of course skip that. And if it's not a form field, then it's a file item, and then we can then read the file, store the file, and do everything we want with the file, and so on. So this is something you would do if you just use regular Java servlet without Spring and with the Commons file upload library. With Spring, things become even easier. We just need to add something called a multi-part resolver bin. And what this bin does is it will automatically use an underlying library like Commons upload to parse the to parse the request, get the file or files, and then we can simply use those files as a parameter in our controller, just like pretty much every other parameters for controllers. Now, let's do this. Let's do an example here. So I'm going to, before I create a controller, let's first add the dependency. So we need comments file upload. And then we need to add a multi-part resolver bin. Let me get that from CSS. It's in here, I believe. Yeah, here. So for this type of things, you don't exactly have to remember the class name and so on. Just take an example, copy it over, and that's the easiest thing to do. So I'm going to copy over that bin, and this bin will use comments file upload to parse the request, and then we can create our controller. So let's do that. I'm going to create a controller called file controller. This one, of course, is a controller. Oops. Yeah. And we'll handle file upload at request mapping upload.html. Method should be request method post. So, like other parameters, we'll say request param, and this time the uploaded file is a multi-part file parameter, and then we do something with the uploaded file, and then we return to redirect to the home page, something like this. Okay, so the question now is what can we do with this uploaded file? Presumably Spring has already parsed it out from the request and pass it on to this upload controller method. If we look at the documentation, we can see that this multi-part file has only a few methods, but all of them are pretty important. So if we want, we can get the whole file as a byte array. So this is something we can do. We can get the content type of the file. We can get the file as an input stream. We can get the name. Notice that this is not the file name. It's the name of the parameter in the multi-part form. So in other words, that name is actually this one. So you probably don't want that. If you want the file name, you can say get original file name, get the size of the file, check if the file is empty, and the last one says transfer to another file. And this is this is what we are going to do. We are just going to simply transfer this uploaded file to somewhere else on the disk. But as you can see, you can do many other things with this file. Okay, so what we'll do is, where is my? We'll save this file under webinf files. So I'm going to create a folder here called files. And after a file is uploaded, I'll save it to there. Now, if you remember, the path to this folder is not the path to the project folder and then here. Remember that when we run a web application, that web application is deployed somewhere else on an application server. So to get the path or the location of this folder, we cannot simply use the path to the project folder. We'll have to do something else. And that something else requires us to access the servlet context, and that gives us the actual path where the project is deployed. So to get a servlet context in a Spring controller is actually very easy. So we just need to say auto-word and then servlet context. And the Spring framework will automatically inject a servlet context into this controller, and then we can use that to get the actual path of this folder. I'm going to create a method for that because later on we'll use the same method when we download the file. So we'll say get a file directory, and let's say it return a Java file object instead of just a string path. So the path would be context get real path, and it should be webinf/files, and then we say new file path. Okay, so this gives us a file directory where we want to transfer this file to. So we'll say file transfer to, and we'll create a new file with the parent folder to be the directory, and then the name of the file is file get original file name. And that should be it, except that it will throw some exceptions. That's okay. Okay, so let's try this. So we'll run the server. And we'll go here, we'll upload this text file, we'll say upload. Oh, forgot to change this back to upload. Okay, refresh, let's try again. Okay, looks like it worked. And if we do a refresh here, nothing happens. Again, remember that this is not the actual folder where the file is uploaded to. It's uploaded to the place where the application is deployed. And that place is under the workspace, under metadata, under plugins, and that plugin is called Org Eclipse WST Server Core and temp 0 and the web WTP web apps and CS jobs and the files. And you can see that it is indeed uploaded here if we open that up. And if we do this again, and this time we upload the PowerPoint file, and as we can see now, this one is saved here too. Okay, so as you can see, the code is very, very simple. So in other words, uploading a file or handling an uploaded file is not difficult at all. There are libraries to parse the request to pick out the file, and the Spring multi-part resolver bin will automatically get the file out of the request and pass it as an argument to your controller. And once you get that file, you can do pretty much what you want. If you just want to save the file, it takes only a couple of lines of code. So getting an uploaded file is not difficult, but it's worth discussing where we should save it or what we should do with it. Generally speaking, we can store an uploaded file either in database or on disk, like what we just did. Storing on disk is usually much faster because the file doesn't need to go through any processing by the database system. However, an uploaded file is usually part of some record, and other data in the record is usually stored in a database. In this case, storing the uploaded file outside the database may lead to some data inconsistency problem. For example, consider a job application which includes some applicant information and the uploaded resume. Suppose the applicant information like name, address is stored in a database, and the uploaded resume is stored on disk. If we want to delete the job application, it would take two separate operations, one to delete the applicant information in the database and one to delete the resume on disk. Because the database ACID properties do not apply to operations outside the database, there will be a short period of time when the applicant information is deleted but the resume is not, or vice versa, depending on which operation is performed first. So for a moment, how brief it may be, the data in the system is inconsistent, and it's up to the developer to decide whether such inconsistency is tolerable. So to summarize, storing uploaded files on disk is more efficient, but may cause data inconsistency problem, which may or may not be a big deal, depending on the web applications that you work on. So if we can upload a file, we should be able to download it, and let's see how we can create a controller to download the file we just uploaded. Now, it's something we actually did before when we take a previous Java web programming class. And where is it? Yeah, it's here. So to download a file is pretty easy. What we need to do is simply reading the file and then write it to the response. And that's more or less it. We can optionally also set some content type, set some header, and so on. So, but the core of it is simply reading the file, write it to response, and that's more or less it. So what we can do is we can do something like this. So we'll create a controller, and this one is going to be called download. And this one, let's say it doesn't have any request parameter. And it will read in the file and write it to response. Reading the file we can kind of do, and after that let's redirect back to the front page. So we know how to reading the file, and that's this. So we create a new file input stream, and the file we are going to read is again under the file directory, and let's see, we want to read in test1.txt. So it's test1.txt. And then what happens? Right. Then we need to write it out to an output string, and that output string goes to HTTP response. So there's no HTTP response in a Spring controller method. If you remember our discussion about Spring Web MVC, we said that if you need one, just put it as a controller argument, and that's it. So what we can do is we do something like this. So when Spring sees an argument that is of HTTP servlet response type, it will pass the HTTP response object to this controller method. So again, this is the Spring philosophy about controller method. If you need something, put it in method, put it in as a method argument, and then we have our output string, and then we read in the file and write it to the output string, and that we know how to do with a byte buffer, and we can close the input. Now it will be nice if we also set a couple of headers. So we'll say the file we are trying to return is a text, plain text file, and let's say we try to display it inline, and the file name is test1.txt, something like this. And this one will be download HTML. Okay, so okay, so we did redirect. No, sorry, made a mistake. So what we are doing here is we are manually populating the response, right? We are reading a file and write it to response. So we shouldn't return a view anymore. because a view is a response and we already created the response. So when we manually created the response, instead of returning a view, we should return null. Basically tells Spring that I have already created the response. I don't need to use a view to generate this response anymore. Sorry about that. And right, so this time it works properly, and when we click download, it downloads a file and then display the file inside the browser, because that's what we told the browser to do, and it displays the content of the file, which says this file is supposed to be uploaded and so on. Okay, so this is how we can download a file, and there are several points I want to just emphasize. The first, the most important one is, of course, including HTTP servlet response argument if you want to access HTTP response directly, and if in that case you should return null for view, because you manually created the response. You don't need to use a view to generate the response. And if you forgot how to use Java I/O classes like input stream, output stream, and the files class and so on, please review the API documentation. And this one also uses a content disposition header, which is a header you use to tell the browser what's the actual file name that it just retrieved, and whether to show the download file dialog box or just display the file directly in the browser. Okay, so moving on, the last subject I'd like to discuss is exception handling. We know that there are two types of exceptions in Java: checked exceptions and runtime exceptions. Checked exceptions are exceptions that you either need to handle with a try-catch block or declare in the method header, like what we did here. And runtime exceptions, on the other hand, do not have to be explicitly handled or declared. A good example of a runtime exception is the null pointer exception. You never need to say, for example, this method could throw a null pointer exception or catch a null pointer exception. One complaint people have against Java is that Java has just too many checked exceptions, and we just saw a few of them here, and it forces developers to write lots of boilerplate exception handling code. Spring's approach to this is that it uses primarily runtime exceptions itself, and it also provides exception handlers that can be used to separate out exception handling code from regular application logic. In particular, you can use an exception resolver to handle all exceptions thrown by controllers. Spring provides a simple mapping exception resolver class that can be easily used to display different views based on the type of exceptions. So again, we'll copy over something from the CSS2 project, and yeah, so it's something called exception resolver. And yeah, it's here. So let's put it here. And CSS2 uses a customized exception resolver class. We don't want to use that, so let's get the Spring one. So it's called simple mapping exception resolver. And what this one does is it lets you to display different views based on different exceptions. For example, we can create a view for access denied exception. For mail exception uses a different view, and for everything else there's a default view and so on. So I'm not going to create a bunch of views, just a default one, and I'm going to call it just error. So notice that the value is a view name. It's not a path to a JSP file. It's a view name, just like other views in Spring. And that view, of course, needs to be resolved into a JSP file. And based on the view resolver, we know that we should create that view under webinf.jsp. So I'm going to call it error.jsp, and we'll say error has happened. Okay, so let's create an exception. Yeah, let's try creating an exception. Okay, so if we don't upload anything, we should get an exception for missing. Yeah, we got an exception for missing a required request parameter, and instead of displaying some default page, it automatically shows the error page we just created. And this is pretty nice because first you can separate out your exception handling code into a separate class instead of mixing it together with your application logic. And secondly, you don't have to do lots of try catch and exception declaration and so on. And then of course you can also customize the error messages based on different exceptions. And again, you can also check out the example in CSS2 and to see in particular how to create and use your own exception resolver. And that is it for this lesson.